Multiplication of vectors. In fact, in this question, we are trying to review what we have done in these 4 chapters. So this is a test problem. It says true or false. Explain your answer. Part A is, when applying the triangle law to add vectors, the resultant vector must be drawn from the tail of the first to the head of the last vector. Question number B is, scalar multiple of vector v such as k times v, m times v and nv are not collinear. C. M plus n within brackets times vector a equals to m times vector a plus n times vector a is the distributive property of vector addition. And D is, given vector v and magnitude of v equals to 4, a unit vector in the same direction as v is v equals to 1/4 of vector v. So that is the unit vector. True or false? So I'd like you to go through these questions and then answer. After answering, also justify your answer, right? Here are my solutions. The first one, when applying triangle law to add vectors, the resultant vector must be drawn from the tail of the first to the head of the last. So let's just add 2 vectors using triangle law. So let us say this is my first vector, and in triangle law we place the other vector with tail on the head, and the resultant is, of course, this, right? That is from the tail of the initial one, the first one, to the head of the last one, correct? If we have more than that, then also it will be same. So the first one is true for us, right? So this is true. Part B is, scalar multiple of vector v such as kv, mv and nv are not collinear. Well, if we have a vector v, for example, this is my vector v, and if I multiply by any number, 1, 2, 3, 4, minus 5, whatever, then what will I get? I will get all the vectors in the same direction. K actually changes the direction, but it can become opposite, right? If k is negative, then we can get a vector like this, right? But still, it can be translated and placed in the same line. So what we get is, if I multiply with any scalar, then I can scale it, right? Like this or like this. But all of them remain collinear, correct? Therefore, this one is false. So all the vectors remain collinear when we have a scalar multiple. In fact, that is a property. If the vectors are collinear, then they are scalar multiples. So you have a value of k which can say that if u is a vector and if they are collinear u and v, then u equals to k times v. There will be a scalar which, when multiplied to the other vector, gives you this vector, right? So that is the relation. Part C is, m plus n times vector a equals to ma plus na. Well, this is a property. Now, is this the distributive property of vector addition? I have seen many students making a mistake here. It's kind of tricky, right? It is not called distributive property of vector addition. It is scalar multiplication. You see that? And therefore, it is called associative law for scalars. So the name of this property actually is associative law for scalars. So this is false. The last one is, given vector v and its magnitude equal to 4, a unit vector in the same direction as v is 1/4 of v. That's correct. So when you divide the vector by its magnitude, what you get is magnitude 1 and the same direction as the given vector. So this is true for us. So that is how you can answer these questions. Thank you.